Example 1, dividing powers with the same base. Math with Mr. Williams. So A, we have 2 to the 6th power divided by 2 to the 4th power. So we're going to use our quotient of powers property. So that means to divide powers with the same base, we subtract their exponents. So we have 2 to the 6th power, and we're going to take away 2 to the 4th power. So we're just going to subtract those two exponents. So 6 minus 4 is 2. So 2 to the 2nd power. Now, of course, we could always multiply this out, 2 times 2, which would get us 4 as an answer. All right, so for B, we have negative 7 to the 9th power, and we're dividing by negative 7 to the 3rd power. Okay, same basis, so what we need to do is we need to go ahead and subtract those exponents. So we have negative 7, and we take away the exponents, 9 minus 3, and 9 minus 3 is 6, so negative 7 in parentheses to the 6th power. All right, for C, we have h to the 7th power divided by h to the 6th power, so we just subtract our exponents here. So h is 7 minus 6, so h to the 1st power. 7 minus 6 is 1. So in summary, to divide powers with the same base, we subtract their exponents. Example 2, simplifying an expression, math with Mr. Williams. So we have simplify 3 to the 4th power times 3 to the 2nd power divided by 3 to the 3rd power. Write your answer as a power. Okay, so the numerator itself is a product of powers. So what we're going to do is we're going to add the exponents in the numerator first. So we have 3 to the 4th power times 3 to the 2nd power over 3 to the 3rd power. And we're going to add up the top. So we have 3 4th power plus that 2nd power over 3 to the 3rd power. All right, so the top is going to turn into 3 to the 6th power over 3 to the 3rd power. The next step is to use the quotient of powers property. Basically, to divide powers with the same base, subtract their exponents. So we're going to take 3 to the 6th and take away the bottom, which was 3 to the 3rd. So we're just going to subtract the exponents, giving us 3 to the 3rd power. Now we can simplify a little bit more. We would just break this apart into 3 times 3 times 3, which would be 9 times 3, or 9 times 3 is 27 as our answer. But since they want our answer in the form of a power, our answer would be 3 to the 3rd power. Example 3, simplifying expressions. Write your answer as a power, part A. So here we have negative 4 to the 9th power divided by negative 4 to the 5th power times negative 4 to the 8th power divided by negative 4 to the 2nd power. So let's go ahead and start off with rewriting this using our quotient of powers. So we're going to take negative 4, and we're going to do 9 minus 5, and then we're going to multiply that by negative 4, and we're going to do 8 minus 2. All right, so let's go ahead and simplify. So we have negative 4, so now we're going to do 9 minus 5, so that gives us a negative 4. 9 minus 5 will get us 4. We're going to just keep the multiplication, and we're going to do negative 4 as our base. 8 minus 2 is 6. So now we're going to use our product of powers property. We're going to add our exponents here because we have the same base of a negative 4. So we have negative 4 and 4 plus 6. So then we have negative 4 as our base, and 4 plus 6 gives us 10. So our answer will be negative 4 with the exponent of 10 for an answer. So in summary, to divide powers with the same base, we just subtract their exponents. To multiply powers with the same base, we just add their exponents. Simplifying expressions, write your answer as a power, part B. So here we have a to the 10th power divided by a to the 6th power times a to the 7th power divided by a to the 4th power. Okay, so let's go ahead and use our quotient of powers property, and we're going to rewrite this now as a 10 minus 6 times a 7 minus 4. All right, so we have 10 minus 6. It's going to give us a to the 4th power times 7 minus 4 will give us a to the 3rd power. All right, now we're going to use our product of powers, and we're going to add up our exponents. So we have a and 4 plus 3. So that gives us a to the 7th power for our answer. So in summary, we have product of powers to multiply powers to the same base, add their exponents, and we have quotient of powers to divide powers of the same base, subtract their exponents. Example 4, evaluating expressions. Math, Mr. Williams. So here we have a 3 to the negative 4th power. So we know we need to use the reciprocal of that since that exponent is negative. So we're going to rewrite this as 3 to the 4th power, but this time we're going to put it underneath the number 1. So we're flipping them upside down here. So now we're going to go ahead and write this out. So what that really means is 1 with 4 3's. All right, and so that gives me 1 over 81 as an answer. Let's go on to the next one. So, negative 8.5 to negative 4 times a negative 8.5 as a base times a positive 4. Okay, well, we know we can just use our product of powers property. So what I'm going to do is I'm going to rewrite this as negative 8.5 and then negative 4 plus positive 4. Well, negative 4 plus a positive 4, well, that gives me 0. Let me rewrite that now. Negative 8.5 to the 0. And I know that if I have a 0 property involved, that means my answer will be 1. All right, C, we have 2 to the 6th power divided by 2 to the 8th power. So I know I need to use my quotient property. So here I have 2 to the 6th power, and I'm going to subtract the 2 to the 8th power by doing the exponents, 6 minus 8, and that'll give me 2 to the negative 2 power. Now I can't leave it like that, so I need to change this into a fraction. So I have 1 over 2 squared. All right, and so I know 2 squared is going to give me 1 with a 4 on the bottom. So 1/4 will be my answer. By simplifying expressions. Math with Mr. Williams. So here we have a negative 5x to the 0 power equals. So here we have the 0 exponent rule in play. So I'm going to rewrite this as negative 5, and that x to the 0 power, guess what? That's just going to turn to the number 1. So negative 5 times 1 is just a negative 5. Is our answer. So we have B, we have 9y to the negative 3rd exponent over y to the 5th. All right, so let's go ahead and use our quotient of powers property here, and we're going to rewrite this as 9y negative 3. Now, since we are dividing by that y to the 5th power, we're going to subtract 5 on the bottom here, and that'll give us 9y to the negative 8. All right, now I can't leave it with a negative exponent there, so I need to change this around to 9, and that y is now on the bottom with 8 for the exponent. All right, so let's go on now. So we have c n to the 4th power times n to the negative 7 over 6. So let's go ahead and use our product of powers rule here, and we're going to go ahead and add up our exponents on top. So we have n 4 plus a negative 7 over 6. So here we have n 4 minus negative 7, get me a negative 3 over 6. And I'm going to rewrite this now as 1 over 6 n to the 3rd as my answer. So remember, for 0 exponents, anything to the 0 power is going to get you 1, except for when it's 0, then it's undefined. If it's a negative exponent, remember we're using the reciprocal. We're basically taking whatever that number is, if it's on the bottom or the top, and we're flipping it to the denominator or numerator.